Hello everybody, my name is Yasser Sammour. I'm an MD candidate at IU School of Medicine in the class of 2025, and I'm going to be talking to you about the components of SedLine brain function monitoring. This is a measure for depth of anesthesia, and important components include the EEG, PSI, and DSA. These are listed as 1, 2, and 3 respectively, and point 4 is where we'll talk about a concept known as burst suppression that's part of the DSA. The first component is the EEG, and this shows brain frequencies that represent brain activity. This includes the alpha, beta, delta, gamma, and theta waves, and you can see here that both the left and right hemispheres are shown. The next component is the PSI, and this is an analysis of EEG patterns. This is related to the anesthetic depth. The data is slightly delayed, but it's displayed on a scale of 0 to 100, as you can see here, where 0 represents suppression of EEG and 100 representing fully awake and alert. PSI for general anesthesia is commonly 25 to 50 PSI. The next component is the DSA, and again this is derived from EEG data. Data is more immediate than PSI. The y-axis represents frequency of waves, the x-axis represents time, the z-axis is the colors, which represent power of a given frequency. The warm colors are higher power, cooler colors are lower power, and again you have both the right and left hemispheres represented. The white line shown here and here is the frequency at which 95% of power is found at a given time. Higher amounts of power at higher frequencies correlates with higher levels of consciousness. The final component we'll talk about is these black bars here. This represents burst suppression, and this represents brain inactivation. Now this can be beneficial in patients with brain injury, but can cause post-op cognitive deficits in elderly, and again is a measure for depth of anesthesia. Here are my resources, and thank you so much for listening.